So firstly what we will do is we'll understand the question. So the question is asking from us is that, so there is Abdoji and he has 10 mansion and he wants to divide this 10 mansion among his 3 children. So when dividing the mansion, he puts up one condition saying that no two children should no two child should receive the same number of mansions. So following that restriction, what we can do is we can divide the 10 mansions into 3 distinct groups such that no two group contains the same number of mansions. So we can do the division into this kinds of group in 4 such ways. So we can do this firstly by dividing it into 1, 2 and 7. Secondly, we can divide it into groups of 1, 3 and 6. Thirdly, we can divide it into 1, 4 and 5. And lastly, we can divide it into 2, 3 and 5. And get all of the other groups by interchanging the position of these numbers. So while solving this question, what we need to understand is that this is a counting problem, and basically in counting problem there are 2 types. So we can either count things that are classified under distinguishable or non-distinguishable. So in this case, the mansions are what identified under distinguishable objects. So if I say there is 3 mansions, 1, 2 and 3, and I am supposed to get 1 mansion out of these 3 mansions. So if I get mansion 1, that is one way, and if I get mansion 2, that is another way, and these 2 are different from one another. So now to divide or to find number of ways in which Abdoji can divide his 10 mansions, what we'll do is we'll assign variables to each of the mansions. Say we'll take the variables A, B and C, and what we will do is we'll assign each of the 10 mansions one of these variables. So as we have discussed earlier, we have 4 ways in which we can group the 10 mansions. So what we'll do is firstly we'll count the number of ways in which we can assign the variables if we group the mansions in the first way. So we have 1, 2 and 7. So what we'll do over here is that we'll give 1 mansion the variable A, 2 mansions the variable B and 7 mansions the variable C. So now to count the number of ways in which we can assign this variable, so it's simple. So we have 10 factorial ways in assigning the variables, but we have 1a, so we divide by 1 factorial, we have 2b, so we divide by 2 factorial, and we have 7c, so we divide by 7 factorial. And we do similar casework counting for all of the 4 cases. So for 1, 3, 6, we have 10 factorial divided by 1 factorial divided by 3 factorial divided by 6 factorial. Do the same casework counting for 1, 4, 5. So we have 10 factorial divided by 1 factorial divided by 4 factorial divided by 5 factorial, and we do the same for the last case, which is 2, 3, 5. So we have 10 factorial divided by 2 factorial divided by 3 factorial divided by 5 factorial. So we have all of these cases. So what we'll do is we'll add all of the number of cases. So we add 10 factorial divided by 1 factorial, 2 factorial, 7 factorial, plus 10 factorial divided by 1 factorial, 3 factorial, 6 factorial, plus 10 factorial divided by 1 factorial, 4 factorial and 5 factorial, plus the last one, which is 10 factorial divided by 2 factorial, 3 factorial and 5 factorial. Now at the end, what we'll do is we'll multiply all of this by 3 factorial. We do this because in each cases we have 3 factorial ways of assigning the variables a, b, c to the 3 childs. So what we are doing over here is that we are corresponding the letters to the ownership. So what we are trying to see over here is that all of the mentions that are assigned the variable a belongs to the son that has been given the letter a, and similar is for b and c. So if we add all of these cases and multiply by all of these numbers and multiply that by 3 factorial, we get 29,880 ways of dividing the 10 mentions among his 3 child, following the condition that no two child receive the same number of mention.